going to talk about static electricity. But first, to understand static electricity, we need to learn about the nature of atoms. So, if you want to know more about this, please keep on watching. All matter has an atoms, and the atom is the building block of matter. It consists of three particles, which is namely negatively charged particle, which is the electron, positively charged particle, which is the proton, and neutral charged particle, which is the neutron. Each atom consists of equal number of protons and electrons. What is static electricity? Static electricity is the result of imbalance between negative and positive charges in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. One way to discharge them is through a circuit. What causes static electricity? Occurs when there is a buildup of electrons on something, giving it an electric charge. What causes static electricity? It occurs when there is a buildup of electrons on something, giving it an electric charge. The buildup of an electric charge can cause dangerous sparks.
Everything you see around is made of the defining structure of elements called atoms. They cannot be seen through the naked eyes and contain positively charged protons, negatively charged electrons, and neutral neutrons. Most of the time, an atom remains neutral, that means same number of protons and electrons. But when an atom has protons and electrons in odd numbers, electrons get excited. Protons and neutrons don't move around, and mostly it is the electrons that tend to bounce. So, when a person or any object has extra electrons, it creates a negative charge. These electrons thus get attracted to positive electron as opposite attracts of another object or person and vice versa. The shock that we feel sometimes is the result of the quick movement of these electrons. Static electricity is caused when two materials are rubbed together. Charge imbalance occurs when electrons are loosely bound in an atom. They migrate easily between surfaces. The body that loses electrons becomes positively charged. But nature always tends towards balance, so electrons always either jump off the surface or jump onto the surface in order to reach equilibrium. As I've said in slide 1, opposite charges attract and same charges repel. Examples of static electricity. Lightning is also an example of static electricity. Lightning consists of pure static electric sparks that jump from cloud to cloud or from a cloud to some object on the earth. They usually occur during a heavy rainstorm or thunderstorm. Turbulence in storm clouds create static electric charges that build up until they are released as a stream of electrons that create a bolt of lightning. Air is superheated until it glows white hot and creates a shock wave that is the sound of thunder. Lightning is extremely powerful and can cause damage and harm, but it is also beneficial to the earth. Static electricity is common when the air is dry and the humidity is low, so it is much more frequent problem in the winter months when the air is cold and dry and indoor heating removes moisture from the air. Problem static electricity can also occur year-round in places with a dry climate. Your pet's fur will build up a small electrical charge and sometimes the fur may even visibly stand on end. When you touch your pet, you both may receive a small shock. In the first picture, we can see that the boy got shocked upon touching the doorknob. Attraction among opposites is a natural phenomenon. Your body is always carrying a negative charge. When you reach for a door handle, the negative charges continue to increase until there is some uncertainty or imbalance created. Once you reach an imbalance, the charges on your hand and metal interact, and due to that imbalance, that metal gives you a shock acting like a spark. In the second picture, the balloon is sticking into the hair of the girl. Static electricity is being created and a transfer of electrons occurring when you do this. The balloon may take the negative electrons in your hair, leaving the balloon with a negative charge and your hair with a positive one. Since your hair is now missing negative electrons, it will move towards them. It is the classic idea that opposites attract. The static electricity in this situation is due to an excess of a certain electric charge in an object, although static electricity can cause many different actions. History of static electricity. Static electricity is one of the oldest scientific phenomena people observe and describe. Greek philosopher Thales Miletus made the first account in his 6th century BC writing. He noted that if amber was rubbed hard enough, small dust particles would start sticking to it. Theophrastus followed up on Thales' experiments by rubbing various kinds of stone and also observed the power of attraction. But neither of these natural philosophers found a satisfactory explanation for what they saw. It took almost 2,000 more years before the English word electricity was first coined, based on the Latin electricus, meaning like amber. Some of the most famous experiments were conducted by Benjamin Franklin in his quest to understand the underlying mechanism of electricity, which is one of the reasons why his face smiles from the US $100 bill. People quickly recognized electricity's potential usefulness. In the 18th century, people mostly made use of static electricity in magic tricks and other performances. For instance, Stephen Gray's flying boy experiment became a popular public demonstration. He used a Leyden jar to charge up the youth, suspended from silk cords, and then show how he could turn book pages via static electricity or lift small objects just using the static attraction. The Leyden jar is a simple device that stores static electricity in large amounts. It was the original form of the capacitor. The Leyden jar was used to conduct many early experiments in electricity, and its discovery was of fundamental importance in the study of electricity. Previously, researchers had to resort to insulated conductors of large dimensions to store charge. The Leyden jar provided a much more compact alternative. Ben Franklin performed many electrical experiments using these devices. In 1663, Otto von Guericke invented the first electric generator, which produced static electricity by applying friction against a revolving ball of sulfur. In 1672, he discovered that the electricity thus produced could cause the surface of the sulfur ball to glow. Hence, he became the first man to view electroluminescence. Guericke also studied astronomy and predicted that comets would return regularly from outer space. Uses of static electricity. Static electricity can also be useful. Here are some examples from industry and everyday life. Static electricity is used in pollution control by applying a static charge to dirt particles in the air and then collecting those charged particles on a plate or collector of the opposite electrical charge. Such devices are often called electrostatic precipitators. Factories use static electricity to reduce pollution coming from their smokestacks. They give the smoke an electric charge. When it passes by electrodes of the opposite charge, most of the smoke particles cling to the electrodes. This keeps the pollution from going out into the atmosphere. Your photocopier or Xerox machine uses static electricity to copy print to a page. This is done through the science of xerography. One version of this device electrically charges ink so that it will stick to the paper in the designated areas. Another version of a photocopier uses charges to stick the ink to a drum, which then transfers it to the paper. Electricity contributes in the inventions and technologies we have nowadays. Some scientists research if static electricity can become the new renewable source of energy. A research entitled Energy Scavengers Static Electricity Could Power the World by Ernest S. et al. 2019 stated that static electricity will be one of the source of our renewable sources of energy in the future, aside from the solar, etc. Further researches and experiment will be done to make this possible.